Hello, friends. Welcome back to another episode of Okie Recycling Tour. So, today I am heading out to Atoka to visit the first ever commercial scale lithium ion battery recycling program. I am super excited to learn about this program. As we all know, technology is improving, and a lot of us have cell phones and some kind of um, electronic devices. And those electronic devices, after they've been used and have reached to their end of life, obviously we're going to throw them away. And those batteries in those devices, if not properly disposed of or recycled, can cause some significant environmental and safety issues, such as fires because of their tendency of being flammable. And also, if um, not properly taken care of or disposed of, the metals found, those toxic metals found within those batteries, have the tendency of contaminating our soil and groundwater. And a lot of us out there rely on groundwater for drinking purposes, and we really don't want to get ourselves um, in contact with those toxic substances. So it is really amazing that there is a company in Oklahoma that recycled these batteries and gave it a second life and continue that cycle and use those batteries again in a different forms. So I am really excited to learn more about this program, and I hope you do as well. So could you please tell listeners about yourself and your company?
Yeah, so I'm Kevin Hobby. I am the VP of Operations for Green Line here in Atoka. And what we've got going on here is we have built the first recycling facility that takes black mass all the way to cathode and anode material in one go. So typically what happens is companies will take black mass and that gets shipped overseas, usually to China. They control about 96% of the market. And at that point they're divided out into sulfates, and then those sulfates are converted into hydroxides. Our system kind of cuts all that out, and so we can build this domestic recycling circular economy here.
This is great. And as I was driving in, I really love your facility. So, and I hear that you're originally from Oklahoma. When did you guys start operating this facility?
So yeah, I am. I'm actually originally from Atoka here, this little bitty town that we're in. And I got the opportunity to come back and do this here with Green Lion. We started building this out early last year, and then we became operational late March, early April, and we're ramping up production now and getting ready to do an expansion.
Great, awesome. It's nice giving back to your little
Yeah.
community. It's awesome. All right, so how many locations do you guys have?
So globally, we have five. We have the site here in Atoka. This is our North American facility. We're looking at building one in Canada, but we haven't really finalized that yet. We have two sites in Europe. One is in Germany and one is in Slovenia. And we have our Singapore location and our Australia location right outside of Melbourne.
Great. Awesome. So, how significant do you think this Atoka plant is to local citizens?
Well, to local citizens, it's a pretty big deal. So if you look at we with our expansion plans, we're looking at bringing 200 jobs to this community by 2027, and we're going to generate somewhere between 50 and 150 million in sales tax over the next 2 years, and then with that, we're bringing these jobs. So if you look at Atoka County in particular, median income is about 21,000. Our lowest paying job here is 40.
Awesome.
So we really are working on also investing back into the community, because coming from here, one of the things is like, well, you're either going to be a hairdresser, a nurse, or you're going to leave and go to the oil field. Um, my hairdressing skills were pretty low. I don't look good in scrubs, so I went to the oil field, and those are your only options. And now I'm back, and I'm giving this community um, opportunities to kind of go with this advanced energy and recycling. And we're doing that through, we have an internship program where we're investing in the local Kaimishi Technology Center to expand their automation and electrical program. We're bringing interns in. We're working with Southeastern University on expanding their chemistry program. We're doing the same with ECU, and we're working with OSU in the same to kind of give the community an option of another path to stay here and keep our kids in this area.
Great. I love all the opportunities that you're creating for citizens and working with higher education to make sure you get the word out. Awesome. Um, so, where do you get most of your batteries from?
So we don't actually get batteries here. We take in only black mass. There are black mass production facilities kind of all across America. And typically what we do here, in the beginning we bought it off of the domestic market from local suppliers. Going forward, what we're doing is whoever our end user is going to be, they will be the ones to provide us with the black mass, and then we would recycle that and give them back the product. So that kind of creates this circular economy because everybody has their own secret sauce when it comes to their cathode and anode material, and they really want to keep it to themselves. So it makes it easier for them if we take their black mass and then give them back PCAM, MMH, graphite, aluminum, copper, lithium, whatever it is that they need out of that. And different customers need different things. So going forward, most of ours will come from, say, Nissan, Panasonic, Tesla, Apple, whoever that end customer is.
Right. Awesome. So I'm sure listeners who want to know more about lithium ion batteries, do
Yep.
you want to tell them more about it?
Yeah, so lithium ion batteries have been around for forever. We've had them really in America since the 80s, and they just continuously get more and more economical for their use. When they first came out, they were pretty expensive. Now they're getting cheaper, so you're seeing them in everything. We see, and most people will talk about EVs. That's like the cool thing to talk about right now. But the reality of it is, so we have about 26 metric tons of black mass in our facility right now that we'll process through in the next couple of days. All of that is from cell phones. None of it has come from EVs because if you look at end of life is about 10 years for a battery, and the EVs haven't really been around for 10 years, not in any major capacity anyway. So we have these cell phones and laptops and things like that. When it comes to lithium ion, it serves several purposes in the battery industry because earlier batteries were good at storing energy but not so great at discharging it. Now we're getting into more like high performance uses, so you need faster charging and faster discharge. And so that's where lithium ion really comes in. And not to nerd out too much on you, but if you guys have noticed, really in the past 5 years, batteries have gotten really good at charging. And a lot of that has to do with they've changed the way that we're charging. So every year we're getting way more efficient when it comes to it. But lithium ion will continue to kind of lead that. You'll get faster charging, you'll get more efficient discharge, and things like that.
Great. So one might be wondering, like, what materials can be found in these batteries?
So the big ones are nickel, cobalt, and manganese. Everybody talks about cobalt right now. That's the big thing that everybody's worried about because if you look at most of the world's cobalt, it's Central Africa, and most of that is done through child labor for digging and mining it, and things like that. They're also not so friendly when it comes to human rights and things like that. So overall, companies don't want to have a negative impact on the world by supplying them with more money to continue doing what they're doing, and so Cobalt is a big one. We're able to recover 99% of that from the batteries, and your consumption never really changes. So the thing to think about is we already have enough nickel, manganese, and cobalt in the United States to kind of keep up with our demand. It's just switching from kind of one medium to another if we were recycling it. But we haven't really had a way to recycle it until really the past 20 years with black mass and then going to sulfates, and now with us being able to go black mass directly back into PCAM. You'll hear us use this term PCAM a lot. That's just nickel, manganese, cobalt hydroxide. That's all it is. It's really simple. It's got a hydroxide bond and it can go back into the battery. But we also produce graphite. We also produce lithium. We produce lithium carbonate here. It's a little bit more stable. It's easier for us to handle, and so that's what we produce, and then we allow the end user to convert that into a sulfate or a hydroxide or a chloride, really whatever they want for their end purpose. And then we call it an impurity paste, but it's really just aluminum and copper that comes out, and so there are buyers for that as well. Another thing that's interesting about our process is our recovery rate on what we get out is so high that our what would be considered waste water that goes back into like the city sewage system and stuff is actually right on par with like drinking water. So we don't produce any toxic byproducts because our recovery process is so high. And then in terms of like air permitting, we didn't really know. You'll hear us say this a lot. We didn't really know because nobody had known, and so we brought in some environmental groups. We worked with the EPA and the DEQ, ODQ to kind of figure this out, and we found out that our fumes that we produce are so far below permittable levels where we don't even qualify for getting like an air permit. We just don't produce enough. So our facility is actually cleaner than like your local oil change facility by like a lot.
Awesome. I am really learning a lot, and I'm glad that at least you guys are working very hard to keep those toxic substances off from the environment. But I was wondering, just in case this materials end up getting into the environment, well, not precisely from your company, what do you think will be, how harmful are they to the environment?
So for what we do, and we have really severe steps when it comes to containment. Like our entire unit, if you look at the base of it, there's a gap in there. That's because our unit is designed where if we ruptured any of the tanks, it can hold the volume of itself within it. So it's its own self-contained containment, and then we have a secondary containment outside of that, and then we have emergency pumps and sumps that would move to a frac tank. But in the event that something did get out, what you can have is you'll see really exaggerated levels of sodium because of the sodium hydroxide in the process, and kind of some lithium sulfate and sodium sulfate and all those that are produced as byproducts. That can be really harmful to grass and things like that. For us, we've got to take really good care with this stuff because some of the chemicals that we use could be harmful to the environment, could be harmful to animal life and stuff like that. But we really just push to be even further than like what we're, I guess, regulatory required to. But I think that, and we're seeing this, we're working really closely with ODQ right now because it's such a new industry, what we're doing, and you're seeing this blow up in Oklahoma because kind of organically, Oklahoma has manifested the largest battery recycling economy in the nation. There's us, we're doing the cathode and anode material. You have Blue Whale building their facility in Bartlesville. They'll take end-of-life batteries and turn it into black mass. There's a company that's putting a facility in Muskogee. They're Stardust Lithium. They're doing lithium recovery out of brine water for fracking. As an industry, we've got to push, and you won't hear a lot of industries talk about this, but we really are pushing for this. There's a group of us that have come together. We're creating a kind of alliance between us to help the governments and local regulatory agencies in order to establish good regulation, because we've seen what happens when there's bad regulation, and a lack of regulation is going to be worse for us than any regulation that can be put in place, because if something did go wrong, there's the potential for it to go very, very wrong. And even though we're being good stewards, there's no guarantee that everybody's going to be good stewards. And so we've really got to push for good, thoughtful regulation whenever it comes to this. And I think you'll see more of that come out from our group and some of these other groups working with Canoe and them in pushing this kind of forefront to make sure that the regulations are there to protect the environment, because it is going to be a huge industry. And as you know, people will find ways to do it cheaper, and if they can cheapen out by being a little less clean, they will, and we need to prevent that head on at the beginning.
Great. I definitely love your process. So could you dive more into how your recycling process works?
Yeah, so what we do when we take in the black mass, we have a four-stage process. So in stage one, what we're doing is we're separating out the graphite. So we'll liquefy it and use a leaching process to dissolve almost everything. Graphite won't dissolve, so then we filter that out. And we've got our graphite, maybe a little bit of carbon black, which is basically the same thing. It's just the molecular structure is a little different. And then in two, that's where we remove our impurities, aluminum, copper, maybe a little bit of chromium. It kind of depends on the batteries that are going into the black mass, but aluminum and copper are your big ones. And then in stage three, that's our patented hydrojuvenation process. That's where we're precipitating PCAM, co-precipitating PCAM, and getting the shapes that we want. So you have some companies will want a product called MMH, which is a mixed metal hydroxide. And some people will want a PCAM. And the only real difference between it is the performance. So if you look at PCAM, it has a round, it's like an egg shape. And so if you can imagine inside of a battery, those egg shapes stack on top of one another with little gaps, and then the lithium can kind of go in there. And it makes it easier to charge. Because if you think about the way that I always explain batteries and charging to people is you need to think of it like a parking lot, right? So when you have a big empty parking lot, it's easy to find a space. You can get a bunch of cars in there really fast, right? The more spaces that get filled, the longer it takes for you to find a parking spot, which is why you'll notice your battery, when it gets to like 80%, it takes almost as long to get from 80 to 100 as it did from 0 to 80. It's because those little electrons are trying to find places to go. So when you stack them with that egg shape, you get a better charge because there's more space for them to go. MMH is flat, so it stacks almost on top of one another, and then the lithium kind of fits between the rows, and it's just not as efficient, but some people prefer that. And so once we've done whether it's going to be MMH or PCAM, we kick that out, and what we're left with is a lithium and sodium sulfate brine. And then we move that to another unit that sits outside called the MLD unit. And what it does is it crystallizes the sodium sulfate on one side and hyper concentrates the lithium. So we evaporate off the water, and we'll put in like 6,000 liters and we'll get out like 1,500, but it's really concentrated lithium. And then we'll pull that back into our GLMC, and that's where we'll convert it from lithium sulfate into lithium carbonate. And lithium carbonate is significantly less soluble, and so that'll just drop out and solidify, and we can remove it. And then what we're left with is basically like a slightly salty water.
Good. All right. So I was wondering, like, what do you do with your finished product?
So with graphite and your NMC, your nickel manganese cobalt, or your nickel cobalt manganese hydroxide, those will typically go immediately back to a buyer. We sell to domestic buyers because we're really pushing this keeping it in America thing. With the impurity paste, the aluminum and the copper, typically we have buyers for that, but it's usually not the battery manufacturer, the cell manufacturer. Usually people that buy that are like scrappers that are going to scrap that out, because aluminum and copper are so cheap and readily available that it doesn't make, it's almost not worth them paying for us to ship it. for these cell manufacturers. And then with the lithium, we have actually a couple of different customers for that. So we, depending on lithium prices, how they fluctuate, some customers will want that back for their battery. But if they don't, what we'll do is we can convert it into different forms, and typically we'll convert it into a lithium that's sold to pharmaceutical companies.
Okay, awesome.
Yeah.
So, also about the waste or things that you don't need from the process,
Yeah.
where does it go?
So our water goes back into our wastewater goes back into the city's system to treat it. We're doing a white paper on that right now because what's interesting is our sewage that comes out is clean enough and the pH is just slightly elevated where we're actually lowering the chemical consumption for the city of Atoka, because what we're putting in is helping them in their wastewater facility. And then we have a byproduct, which is sodium sulfate. And it's a big problem within the industry. Nobody really knows what to do with this sodium sulfate. What we found is we have buyers that, if you Google sodium sulfate, you'll see that it's mainly used in pharmaceuticals, but its larger use is in laundry detergents. So if you look at like a powdered laundry detergent, most of that is sodium sulfate, and so we'll sell it to them, usually like almost for nothing because it's just this byproduct that we always get, and so we're just a cheaper supplier of that. And then we don't have any waste that comes out. We don't have anything that gets specialty hauled off or anything. You'll see the frac tanks that we have in the back, but what those are for was in our initial runs when we didn't know what was going to be the end product. We were storing it there and testing it, and now when we do new runs, so like let's say, so we're finishing up a production run right now. When we get the next run, it'll be a different type of black mass, and so we'll switch from going to the city sewage system to those tanks again, and we'll hold it and study it to make sure that we don't release anything accidentally that we weren't prepared for.
Great, awesome. Wow. Okay, so why do you think it's important to recycle these batteries?
There's a lot of reasons. I give this speech all the time, and it's kind of silly, but I'll let you guys hear it. So, when you think of things, you think throughout your life, you keep having these, we call them financial mistakes, right? Some of them are big, and some of them are small. Small one is like, you wanted to watch that movie on Netflix, so you signed up for the 7-day free trial, and then on the 8th day, you get charged $20. It's $20, it's whatever. You got one that's a little bit bigger, like you go to Target without a list, and then you walk out of there $500 less, and you're like, man, I got a couch. I just wanted to buy some laundry detergent. What's going on? That's a little bit bigger, right? Global battery recycling is a $1.7 trillion with a T business right now, and China has 96% of it globally. So that's a financial mistake that we can't come back from. There's no recovering from missing out on this, and every year we're missing out on it. And having that domestically, not only you're talking about jobs, you're talking about tax dollars, you're talking about all the things that go into that economically, but also having the batteries here is a good thing. If you look at, without getting super political, but if you look at what's happening between Ukraine and Russia, most warfare is done by drones now. Every one of those drones has a lithium-ion battery on it, and every one of those lithium-ion batteries is made with material that's controlled by China. And China is not our friend, and they could very easily, we've already seen them cut off graphite supply, but they could very easily do it to PCAM and MMH. And then there's no domestic battery supply. And we always hear about one of the things that we deal with here a lot is, EVs aren't really panning out the way that you guys thought it was. Do you think that this is still a thing? And my rebuttal to that is, first of all, you tweeted this at us on a cell phone, which has a lithium-ion battery in it. But second of all, let's take it more personal, right? Everybody's got a phone, everybody's got a laptop, that's cool. But the backup batteries for hospitals, those are lithium ion batteries. So when a tornado comes through Oklahoma and a hospital has to run on backup generations, that's lithium ion batteries. Imagine if we didn't have that. People that are on life support that can't be supported anymore because we're not keeping this domestic and we've been cut off. We see these economic wars happen all of the time. And then another level to it is we we have to do business in order to keep this industry going. We have to do business with countries that don't stand up for human rights, that don't treat people the way that they should be. We have to deal with China. We have to deal with these Central African countries with child labor and stuff. And all of that only goes because there's still money involved. And if you cut off the money supply, then they're going to have to figure out a better way to do it. And if we make a stand and say, look, we're not going to do business with people that don't treat people like people, that's the only way that we're going to be able to change it. Because right now, it doesn't matter how many Facebook posts you put out, it doesn't matter how many tweets. If they're still getting the money, they're still doing it.
All right. I know you've mentioned a lot about the black mass. Would you please tell listeners more about it?
Yes. So all that black mass is people, companies, groups. If you've ever seen like those eco ATMs that are where you put your old cell phone in and they give you money back, or your iPad or whatever, they take these electronics apart and they kind of recoup what is good. And then with the batteries, they go to facilities. There's several facilities in the U.S. They've been in operation for 50 plus years. And what they're doing is they're shredding these batteries, grinding them up into a powder in order to make it easier to ship. Because if you just ship batteries, they can catch on fire and it gets really bad, right? But with black mass, because it's discharged, it makes it a little safer to carry, a little bit safer to transport. But currently, we don't have a good system for recycling it all the way back to where it needs to go, which is kind of where we come in to take that black mass all the way back to the battery material. But black mass is everywhere. Everybody has already seen black mass. They just may not have known that that's what it was. But that's what's happening right now. And we're seeing huge pushes right now with municipalities. The state of Utah has reached out to us. We're working with them. There's a couple of Oklahoma groups like Okra. That's really, we're all trying to get together and help these cities keep these out of the landfills. Not only because you're losing money, but also because they can catch fire. And if you have a fire in a landfill, it's a bad thing. And that's really hard to control. And so keeping these in a well-regulated a well-regulated economy is the best way to do this. We just have to get better at using our own black mass. We make it now and then sell it overseas.
Right. So do you think black mass is hazardous or toxic?
It can be, yeah. Because you have it's such a fine powder. You can breathe it in, and that can be bad. It can also, it's not like self-combustible like it is when it's in the battery form, but it is flammable and it does burn hot. It's not the safest way to do it. I had an interview with a company here not too long ago, and they were discussing, they make black mass. They're one of the biggest black mass producers in America. And one of the things that he was saying is safety's got to be number one when it comes to black mass production, because when we're interviewing people for jobs at our facility, if they say that they've worked at a black mass facility before, we ask them, okay, how many fires did you have? And if they say none, we know that they're lying, because everybody has a fire eventually. And so this stuff, it is dangerous, and it is hard to handle at some points, which is why we don't make our own black mass. We kind of leave it up to the professionals when it comes to that. So it can be toxic, it is flammable, and there are fires that happen at these facilities quite often. I think a lot of that comes down to, like I said before, this has flown under the radar for so long that there's not just a ton of regulation involved in this. And we as a nation, as a people, we need to tighten up from the end user when they're getting rid of their battery all the way to what we're doing. We just need to tighten that up and get better regulations and set a standard out there.
Great. Awesome. I mean, you guys are doing an amazing job. So I was wondering, what are some of the major challenges that you guys your company have faced since you started?
Well, in the beginning, the biggest one that we faced was that nobody thought it could be done. And to be quite frank, we didn't know it could be either. We just kind of had a dream and we made it happen. And then we did it. And then it was kind of like, well, did you really do it? And so we had to do that. And then there's a stigma, both politically and personally, with our industry where people feel that maybe we are pushing this electrification or something like that. So we kind of deal with that. That was a big thing that we had to do with educating the public. And then because it's so new, I mean, we're the first. Nobody knows like what's the danger to my kids, what this facility being there, and we have really had to work to educate people about, hey, this is happening, this is what we're doing, and it's safe, and we can show you. We can show you that it's safe, but it's also needed, and it's not just about EVs, it's not pushing this electrification agenda. This is everything, even down to, if you want to get really, really particular with it, the oil and gas industry which is a big thing in our state, they rely on these lithium-ion batteries already. Every one of their SCADA systems on their tanks is powered by a solar panel that powers a lithium-ion battery. Every call that they make is on a lithium-ion battery-powered cell phone, all of this. And we're not here to take anybody's jobs or push any type of agenda other than we need to keep this here and we need to do this and we really would like you guys' support in it, because if we don't, all of this could go away tomorrow, because that's where we're at right now. The domestic use of cathode material is going to be somewhere in the realm of like 300,000 metric tons a month, and right now in the entire United States, less than, I would say, 700 metric tons a year are recycled.
Wow. Awesome. Good. Definitely, you guys are doing amazing. And I was wondering, just in case, because you're playing with batteries,
Yep.
and there might be danger, there might be some exposure. What's best management practices do you guys have in place to ensure worker safety?
So it's funny, I can take you out there and show you, but when we're first doing the runs, we kind of go over the top with PPE. We have the whole Tyvek suits. It looks like my kid came out one day and we were doing it, and he said it looks like ET, because we have the full suits and the tents and everything. But right now what we do, we have really good air filters. We use misting supplies to keep any type of buildup. We're constantly, so our unit itself is constantly pulling samples of everything, and of both the air, the liquid, the effluent, the solids, and we have backups on top of backups on top of backups for if something goes wrong or if we see something out of place. We do really good PPE practices. We spend a lot of money on PPE, gas monitoring, even things that we know we don't need right now, but we could need in the worst possible situation. We already have it, and we're really trying to get ahead of that. And I think that's always going to be the thing when you're the first in any industry. We don't have a blueprint to look off of, so we just have to go as far as we can in one direction and maybe scale it back. But we're not at the scaling it back part right now because everything's so new.
All right. It's great that you guys are planning for the future just in case something shows up. That shows how much you care about your staff. Okay, so what's your production capacity like per day?
So right now we're doing about 5 metric tons a day of processing of black mass. We are projected by 2027, we want to be, I don't know what it is a day. We want to be around 25,000 metric tons a year by 2027, and we'd like to double that by 2030. So that would, that's going to require more facilities, more machines. We are pushing very, very hard. You guys will see us over the next couple of years. We're going to expand the Atoka site, but we're also going to expand outside of Atoka, but we're going to keep it in Oklahoma. We're really focused on staying in Oklahoma and doing this. We might go to, we're speaking to some people about the Michelin tire facility is shutting down in Ardmore. I think it's 2,000 people are about to lose their jobs. We're talking about that's a good facility that would be great for us to expand into and try and keep these jobs here in this state, because I think that that's going to be a huge thing that we have to focus on, is keeping this industry going in this state as some of these other industries are kind of dying off. And so for us, that's where we'd like to be. But we're processing about 5 metric tons a day right now. We'll double that in a couple of months, and we'll just keep going from there, adding more machines and more people.
Great. I love that. All right. So my last question is, what's your biggest success story since you started?
The fact that we did it, that was really the biggest success story, because it's really easy right now. It's really easy for us we go to these conferences and we get to tell this Steve Jobs, Steve Wozniak in the garage story where we were inventing the future, but 8-9 months ago, we didn't know that this was going to work. We didn't know that we were going to have enough money to make it work. We didn't know that the tech was going to work. We didn't know a lot of these things, and then we did it. And the interesting thing about being first is, I always say, coming from oil and gas, one of the things that is kind of said around there is you want to be the first person to be second, because the first person gets to make the mistakes. But it's been really cool being the first, even with our mistakes.
Great. Awesome. Thank you so much. I've learned a lot about your company and your processes and what you do, and it's super amazing. Thank you for having some time to talk to me.
Yeah, thank you.